Welcome. We've got a fun video for you today. I'm going to be going through the conversations window in the statistics window. I'm going to be doing two things in this video. I'm going to be showing you conversations where we specifically go through a land attack. So that's a network attack. I'm going to do a land attack, and I'm going to show you in Wireshark how to find a land attack. And then I'm going to be going through a particular scan and how we can use the conversations window to help us spot scans and see some of those things that stand out and are kind of weird in a capture. All right, enjoy. What I'd like to do first actually is explain a little bit about the network that we're dealing with here. So I've got a Kali machine here, and its IP address is 2.21, and I've got a Metasploitable machine, and its IP address, as you see on the screen here, is a 5.42. Okay, so those are two different networks, but they're actually both routing through a pfSense machine. So the Kali is on the LAN side, and the Metasploitable is on the Opt1 network. And I've got a rule down here at the bottom that says all TCP traffic from the LAN side is able to make it to the Opt1 network. Connect to it quite easily. A single packet here. Let's send one to port 80 on that machine over there. And we can see that we get a SYN ACK back. So we know that we sent a single packet, a SYN packet from 2.21 over to a different network and then actually got a response back. Wonderful. Let's actually do a land attack against the Metasploitable machine. And essentially, we are going to be sending a packet to another machine and spoofing that machine's IP address and its source port. So let's go ahead and make sure we got Wireshark running here. We're going to start a capture here. Open up this. And now I'm going to create a spoofed SYN packet going towards our target machine. So we're going to do hping3. I'm going to do a SYN, and I'm going to do a count of 1. And the target port is 80. And I'm going to do 192.168.5.42. And now here I'm going to actually spoof it. So I'm going to do -A with the IP address 192.168.5.42 and the source port of 80. We just want to see it happening. So that's going to be a single packet, okay? So let's send it off. We see it right there. And in fact, I'm actually going to change this a little bit. Instead of a single packet, why don't we send a whole bunch of packets, 100 packets. So that's not that many actually. If it was a flood, we would have hundreds of thousands, but we're not trying to prove that we can flood something. We're trying to prove that we can see conversations inside of Wireshark. That's what's important. And we're going to send it fast. We're done. Now I'm going to go over and cancel this Wireshark from capturing any more traffic. We don't need that right now. Expand this, and well, we can see on the screen right away that we've got TCP traffic here. We've got a source of 5.42 going to a destination of 80. And that's actually the flood, by the way, because a new port here, so that even though we chose a source port, we're actually ended up flooding it and choosing a different source port. So that's not totally a land attack, but we can actually filter and find that original one. So let's do TCP port equal 80. Right away, we've got the very first one. That's the one that we sent originally. We got 80 going towards it. And in fact, we can see that over here at this packet number 41, that's actually when we started the flood. And now what we're going to do is that we're going to go to our statistics window and take a look at a little bit of the conversations that are happening inside of this capture. We've got 142 packets, and I'd like to know who's talking to who and how much traffic is actually being sent. So let's go over to the top left here, statistics, and we're going to slide on down to conversations. That opens up our window here, and I like to go over to IPv4. There we are, and we can see that there was some internet traffic here. So between my Kali and the internet, because this is a public IP address. And then we got an interesting thing here is we've got 5.42, and remember that is our land attack that we just did. So we've got 5.42 to 5.42. Now, if you ever see an IP address having a conversation with another IP address that's exactly the same, that's weird. You should be digging into that and figuring out what is going on. What I really, really like about the conversations window is that you can actually right click and filter on the items that you're trying to look at. So like I want to know everything between 5.42 and 5.42. Let's go to selected. And now I can choose the style of the conversation. Is it a back and forth between these two? Is it from address A to address B, B to A to any? Let's go and do a back and forth. So it's selected. I close this, and on the screen we can see all of the traffic that's between 542 and 542. So there's a total of 101, and we know that makes sense because we sent 1 as a single, and then we sent 100 as a flood. Let's go look at another capture to just drive home this point. I really like this file because it has a tremendous amount of conversations inside of a local private network. So we have a capture here. It's got about 34,000 packets, and we're going to pretend we don't know what's going on. So let's go and use the statistics window up here on the top left and go down to conversations and try to get an idea of who's talking to who and is there something that jumps out at us. So I'm going to go over to IPv4. Let's expand this a little bit. And we got a lot of traffic here. And we got a 1.66, 67, 72. These are the private network class C here. And we got a lot of stuff happening between 72. Let's keep going down. I mean, we've got a lot of like public stuff. So we can kind of make an assumption that 72 is potentially reaching out to a public server. Maybe it's a web server. We don't know just yet because I don't know what this IP address is associated with. But it's not inside my local network. I know that. Something that stands out to me here is if we look at this one right here, communicating with another private asset. We have 1.65, we got 75 talking to 66, 75 talking to 67, 75 talking to 68, and so on. That's a lot of communication between this machine and a variety of machines in the exact same network. That's a little strange. And something else that's also strange is that we can also look at the number of packets that's sent. If we see 2,000 around there, another 2,000, another 2,000, 2,000, 2,000, 2,000. Between this machine and that machine, we have roughly about 2,000 packets that are being sent between each of these machines. Why is it such a uniform number? Well, let's dig into it. We're going to right click on this conversation, apply as filter, selected, and I'm going to do back and forth. I honestly always, for the most part, just pick this top one. It's pretty useful. And then I click it, and it brings us to all of the traffic that happened between these two machines. Expand this. I like being able to see that. So let's look at packet 2040 here. It's 175, source port very, very high, to a destination port that's in that reserved range, so 554, and that's actually the real-time streaming protocol, so RTSP, which is associated quite often with an IP camera, so it's got an IP address. It's using an RTSP protocol. Kind of makes sense that potentially I'm dealing with maybe an IP camera. I'd have to do a little bit more digging to figure that out. But let's look at all the packets that are being sent. 37668, 8088, 143, another destination. 8080, that's a proxy one. 443, that's HTTPS. We don't even know if that's running on that machine, but for some reason a SYN packet's being sent there. What we're looking at here is that 75 is sending a lot of SYN packets to this machine here. And it's sending it to very specific low ports that are reserved, that have special purpose, or VNC right there. So what's happening here is that we actually have a scan that's happening. What kind of scan? At this point, we don't know, but we can do a little bit of digging. So let's make our filter a little better here. I'm going to do an open bracket. I'm going to close it. It's green, so it likes it. And then I'm going to actually add and TCP flags equals 0x12. So that would be all the flags that are associated with SYN-ACKs, which would be an open port. So I'm going to hit enter. So let's see what happens here. Okay. Of all of those other packets, only this communication actually has a SYN-ACK, which tells me that when 75 sent a SYN packet to 65, that port was open because it responded with a SYN-ACK. Isn't that awesome? We are going to take out this SYN-ACK, and I'm going to do a TCP port equal 554. So I want to see this communication here between these two machines, but I specifically want to see only this. So that will give me the SYN-ACK, and maybe an ACK. We'll see. Beautiful. So now we can see that we got 75 sent a SYN packet to 65. Okay, great. We know that. We also we previously confirmed that a SYN-ACK here came back to 75. Okay, so that means an open port, and then the 75 machine actually completes that three-way handshake with an ACK. What that's telling us is that it's not a stealth scan. Because it was a stealth scan, there would be no ACK. What it is a TCP connect scan. And the biggest pieces that tell us that is that we got the three-way handshake. It's a full connection. Then we have the sending machine killing that connection with the reset ACK. But additionally, we also have that reset ACK was sent out crazy fast. So full connection, and then boom, a reset ACK is sent to the destination. All right. All of this we learned and got an idea by looking at the conversations window. It's such a useful window. I hope you enjoyed the video. On the screen, you're going to have 2 extra videos that I think you're going to enjoy. Go ahead and give those a watch. Also, there's some merchandise if you're interested, and we'll talk to you soon. Bye.